everyone, it's Alyssa and welcome to You Can Learn Math. Today's lesson is on the distance formula. And when we say distance formula, this isn't like saying distance in the real world, like trying to figure out how far away your house or, where you live is from your neighbor, or how far it is when you walk to the bus stop or to the store, or how far it is to drive to your grandparents' house. That's not what we're talking about. We're talking about something very specific, and it is distance between 2 points on our standard little XY plane. I'm just going to use the graph that's in the background there for all of these. So hopefully that shows up. Okay, so let's say I have I'm going to pick some random points here. I'm just going to pick a point here. This is point 2, 4. And let's say I pick this point over here, which this is point 6, 1. And the question is, if you were to draw a line to connect these two, how long would the line be? What is the distance? Oh, we have a title. We have a name. The distance between these 2 points. Now, the thing that's going to come into play, we are going to have the distance formula. And I'm going to show you the distance formula, but it looks kind of crazy. So, just don't get too freaked out by this. All will make sense in the end, I promise. Or maybe even earlier. You might have an epiphany midway through. So here is our distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Yikes, right? This actually has a basis in something else, which you've probably seen before, which is the Pythagorean theorem. So if I have a triangle, just as a reminder, if this is not ringing any bells, if I have a triangle with a 90-degree angle in it, that is a right triangle, and I label the two short sides A and B, and I label the long side or hypotenuse C, then if I take the length of side A and square it, and I add the length of side B and square it, it equals the length of the hypotenuse, or the long side, squared. A squared plus B squared equals C squared. Pythagorean theorem. Random little math fact, Pythagoras did not discover this. He just proved it and got to slap his name on it. It was actually around 4 centuries before in several different cultures. There's, evidence they all knew it and used it, especially in architecture. Math facts. So this Pythagorean theorem is going to be the basis of our distance formula. And so you can kind of see we got some squares and squares there. We got two things that are squared. We got two things that are squared here. There might be a connection. Well, there is. Right, let's go over to our little graph here. And I'm going to kind of zoom in just on this. I'm going to focus really on this. I'm going to make a triangle with that side, that length, the one I'm trying to find the length of, that line, as the hypotenuse, as the long side. Okay, so now, just like in our previous little Pythagorean theorem setup, this would be A, this would be B, and this would be C. So, according to Pythagoras and all the people that came before him, A squared plus B squared equals C squared. Well, let's say how far A is. Well, I can just count, right? So it's 1, 2, 3 down. So 3 squared. And then how far is B? 1, 2, 3, 4. Okay, so B is 4. 3 squared is 9. 4 squared is 16. So I get 25 is C squared. I take the square root of both sides, and C is equal to 5. And there's my distance. C is 5. Okay. So how does this little triangle that I just drew relate to this monster over here? Like, how are they connected? Well, let's see what I actually did. So what happened here? A squared. I said A was 3. I said it was 3 because I just looked at it and I said, hey, that's 3. What's another way that we could have said, how long is A? Well, this point up here is where y is 4. Down here is where y is 1. So if I said, how far is it from 4 down to 1, you would say, okay, 4 minus 1, or that's 3, right? How about for B? We counted and said it was 4, but if I didn't have a graph handy and I just wanted to know how far it was, I would go, okay, well, the x value is 2, and the x value is 6. 6 minus 2 is 4. Now I know B is 4. Well, that's what this is doing over here. That's what that x2 minus x1, y2 minus y1. Those little 2's and 1's don't mean anything as far as it's not like an x squared where it's telling you to do something like multiply x by itself. No, this x2, x1, y2, y1, they're not telling you to do anything. They are identifying. So if this point, we say is our first point, 2, 4, and then this down here would say is our second point of 6, 1, then this would be my first x, and this would be my first y. Over here would be my second x and my second y. That's all it's saying. Okay? And it's saying to plug these in. Now, you may be asking, but how do I know which one is the first xy and which is the second xy? And how do I know? It doesn't matter. It doesn't matter. It doesn't even matter if you flip them. It really doesn't. Because look, I actually did when I was showing you this example. I said 4 minus 1 is 3. So that was y1 minus y2. But then I said 6 minus 2 is 4. That is x2 minus x1. It doesn't matter because you're going to be squaring it. And if you get a negative or a positive answer, it's going to be the same thing. And I'll show you real quickly, just kind of prove that that doesn't matter. I will show that. I will include that in here to show you that it doesn't matter which one you label as the first or the second. So this x2 minus x1, y2 minus y1 is just saying take your coordinates, subtract them to see how far apart the x's are, and then you see how far apart the y's are. And that was this step right here. And then we added them together, which is this. We added them together. And they said it's equal to c squared, so we took the square root of both sides to get just c, or that distance. And that's where this square root comes from. It's taking that square root. So it is turning c squared. I'm just rewriting it so it lines up with the distance. I'm flipping it across. C squared equals a squared plus b squared. And you go, okay, well, to find how far a was, in this case, I took the y's first, but it doesn't matter if the x's are first or the y's first. It doesn't because we're just adding. I said, okay, one of the y's is 4. I subtract the other y, which is 1. And then I took the x's and I took the 6 and I subtracted the 2. So that was equal to c squared. But then I need to know what c is, so I take the square root of both sides. And looky there, it looks exactly like our distance formula. So let's see this in action, because what you might be thinking is, well, what if the point is like down here? Like if it's negative and it's going up to here, is this still going to work? Yep, it still does. And I'll show you a couple of examples, to show you that this actually absolutely does work. Don't mind me as I sit here drawing a graph. Just sit there. Some teachers like, all right, everyone, just, look at your book for a moment while I sit here and draw a graph. Okay, so I'm going to have this point here, which is 4, 4. And then this point over here, which is -4, -2. All right, and I want to know the distance between them. And I'm going to do this a couple different ways, so you'll see it doesn't matter which ones you label as x1, y1, and x2, y2. And it doesn't matter that these are negative numbers. You're still going to get the same things. So distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. All right. Let's try it first using this as x2 and y2, and we'll call this x1 and y1. Why not? All right, so x2 would be 4, right there, minus x1, which is -4, so minus a -4. Be careful of that. If it is a negative, you're going to have 2's, minus a negative, 2 negatives there. And then y2 be 4 minus a -2 squared. So D is going to be the square root of 4 minus a -4 is 8. 8 squared is 64. 4 minus a -2 is 6. 6 squared is 36. D equals the square root of 64 plus 36 is 100. D equals 10. Okay. So I'm going to, just remember that, D is 10. So I'm going to write that up here. I found that D was 10. And what I got in the second step was square root of 64 plus 36. All right, so that was using this as x2 and this one as x2, y2, and this one as x1, y1. All right, so let's try it. Let's mix it up. Let's get crazy. So let's say, what if I said this was x2, y2, and this was x1, y1? All right, so what do we get that way? I would say -4 from down there minus +4 squared plus -2 minus 4 squared. What does that give us? All right, -4 minus 4 is -8. -8 squared is 64. Plus -2 minus 4 is -6. -6 squared is 36. Oh my goodness, it's the same as before. There you go. All right, and what if you messed up and the first one you did x2 minus x1 and then you did y1 minus y2? Oh, the horror, the horror. Yeah, it doesn't matter. Or what if you put the y's first? It doesn't matter. You just have to put the x's together and the y's together. You cannot, the only way this will mess up is if you do x minus y. That's it. Like if you put an x minus y in either of these. No, it has to be x's being subtracted and y's being subtracted. It does not matter if you do the y's first and then the x's second because you're adding. Doesn't matter. It doesn't matter. I'll show you if you did x2 minus x1, but then you swapped the order on these. It doesn't matter. This is pretty flexible and it's very forgiving. As long as the x's are together and the y's are together and you're subtracting x's and y's, then adding them together, it's going to work out. So if you did that, let's say if I swapped it, like I did 4 minus a negative 4 squared, but then I got it backwards on the other one and I did negative 2 minus 4 squared, so I'm doing them opposite orders, it's still the same. That squaring gets rid of those positive negative issues and makes everything come out. So 4 minus negative 4, positive 8 squared is 64. Negative 2 minus 4, negative 6 squared, 36. You're back to the same one again, where D is 10. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.